Good morning, ladies and gentlemen, boys and girls, friends and neighbors. Let me zoom out here a little bit so I can get a bit bigger picture. So this is inverse function day 2. It's going to look exactly like a day 1, only we're just going to do different problems. Here we go. And note, in Algebra 2, we're only going to consider inverse functions of 2 types of functions, sets of ordered pairs and linear functions. And we will review again the definition of inverse functions. This is the same definition that we will use in pre-calculus. This is going to work on always on inverse functions. So two functions are inverses, f(x) and g of x. They're inverses if and only if f of g of x is equal to x, which is equal to g of f of x. And when we are given two inverse functions, this is the first thing that we're going to check to make sure that they are inverses. And as was stated yesterday, this is a very important, this is a 5-star topic. Not too difficult because we did composition functions last week and earlier this week indeed. So sometimes we will refer to, make no mistake about it, g of x as this f of, this f negative 1x thing. This is not an exponent. How do we read that? We simply read that this is the inverse of f of x. So here I have another example. I'm given two functions. Here we go. I'm given the first function 1/3 x minus 2, and g of x is 3x plus 6. I want to know, dude, are they inverses? Well, I don't know. Let's check it. Let's go f of g. Let's go g of f, and let's see if they both equal s. We're going to start with f of g. Wherever I see x and f, I'm going to put a g. Right here is g. Right there's my g of x. 1/3 times, and I got 1/3 times g of x. 1/3 times 3x is x. 1/3 times 6 is 2. 2 minus 2 is x. Bam, checks that way. Now I need to check to see g of f of x. I'm going to put f of x in g. Here's my little f of x right there. Right there it is. And I'm going to take 3 times f of x. 3 times 1/3 is x. 3 times 2 is negative 6. Add negative 6 plus 6 is what? Is x. Bam. Those are good. There's some very easy problems about this, and this is a very easy check, I think, that they are inverses. If you don't get x either way, they're not inverses. So what statement can I make? I can make the statement that f of x 1/3 x minus 2 and g of x 3x plus 6, they are inverse functions. I'll zoom out and let you get a good picture of that right there. Entire page, right there it is. Take a picture. Take some notes. Let me zoom to 200%. And there's the check right here. This is the important part of that problem right there. And you need to know the definition. Here we go. Page 2. Page 2 is how do you find an inverse? Same thing we did yesterday. How do you find an inverse? This is very important that you know how to find the inverse. Let's go to 300. Let's go out to zoom it out. Okay, the question was, how do you find an inverse function? Note all linear functions where the slope is not 0 have inverses. So here I want to find the inverse of 3x minus 2. I want to find the inverse. Step 1, you need to know these steps. Step number 1 is put y in for f of x. Ooh. Y in for f of x. I have y is equal to 3x minus 2. Step 2, solve for x. How are you going to solve for x? You're going to add 2. And then you're going to multiply the whole blooming thing by 1/3.
Thank you for holding. We appreciate your patience.
Okay. And 1/3 times x is x. 1/3 times y is 1/3 y. 1/3 times 2 is 2/3. Easy enough. That's x right there. What are you going to do now? Now, this is an important step. All you're going to do is swap the x and the y's. Y's become x's, x becomes y. Y becomes x becomes y. And they're getting y right there. Step 4, let y equal g of x. Ooh, let y equal g of x. Right there you go. And guess what? You have found the inverse. This is easy peasy lemon squeezy. It is not difficult. More notation than anything else. And what are you going to do? You're going to check to see if you accurately, correctly found the inverse g of x. So what we're going to do is we're going to recall that f of x was 3x minus 2. We have the g of x is 1/3 x plus 2/3. And we're going to check this f of g and this g of f. So f of g, I'm going to put g right here. It is. Right there is g. I'm going to put it in right that x right there. 3 times 1/3 is x. 3 times 2/3 is 2. X plus 2 minus 2 is x. Bam. Check OK. Now I'm going to find g of f. And you need a bit of, you can always pause the video. Now you're going to put f of x in for that x right there. I got 1/3 times f of x. That's f of x right there. 1/3 times 3 is x. 1/3 times negative 2 is negative 2/3. Right there it is. Plus 2/3 is x. Check OK. So those are the inverses. Good deal. So I found the inverse of a function. Easy peasy. Everybody should be able to do that. Zoom out on this page. Take a picture if you want. Zoom out to the entire page. Take a picture of the page if you want. These are very important steps. You can do it. You can do it. You can do it. Don't tell me you can't. Okay, let's do the next. The next one probably, the next page is probably the hardest. And it's not that hard. And here we go right here, 300. So another interesting fact about inverse functions is that the reflection in these two graphs, one is the reflection of the other about the line y equals x. So if I look at this line y equals x, so this is going to be in reflection. What I have is the red line graphed and the blue line, and you can see I made a pretty picture. The blue reflected about this yellow becomes the red. And all I have to do is carefully sketch these graphs, and it is a careful sketch. So, well, the first thing I did was check to see if they are inverses. That's what you always want to do. So I'm going to put g. This is g right here. I'm going to put g in for that x. Bam, I get 1 negative 1/3 times negative 3 is x. Negative 1/3 times x is negative 2 plus 2 is x. Bam. Now I'm going to go g of f. This guy right here is f. Negative 3 times f. Negative 3 times 1/3 is x. Negative 3 times negative 6. Negative 6 plus x. Good. Check OK. So now let's carefully graph those. Both of those functions and see what we got. So if I graph this red, I'm going to start at the y equals 2. And I'm going to go down 3 over 1. Or down 1 over 3, down 1 over 3. If I'm going to sketch the blue, I'm going to start at 6. This point right here is 6. I go down 3 over 1, down 3 over 1. Connect those dots, and you can see that they're going to intersect always. They always intersect at this line y equals x. That makes sense. Well, I don't know if it makes sense, but everything is connected. So this blue line, if I folded it over the yellow line, would become the red line. We're going to do that a lot down the road, and you're going to need to know how to do it with two linear functions. Okay, one more type right here. Number 4, the inverse set of ordered pair. The inverse of a set of ordered pairs, pretty digging dog daggone easy right there. Here I have f, set of ordered pairs, negative 2, 3, negative 1, 8, 4, 7, 9, 0. And remember that step where you swap the x's and y's? Find the inverse is super easy. You just swap the x's and y's. Y becomes the x. X becomes the y. Y becomes the x. Bam. X becomes, ooh, I made a little error right there, didn't I? That's 8, negative 1. This is 7, 4. And this is 0, 9. Inverse set of ordered pairs are easy peasy lemon squeezy. So that's a 10-minute quick video that should help you. I think I have covered twice now. I've done this video, the problems that are due for Friday. This is an easy lesson, ladies and gentlemen. Inverse set of ordered pairs is easy. Graphing lines. Come on, you can graph lines. We've been doing that since pre-algebra. Certainly did it in algebra. We did it a lot last semester. Finding the inverse, step 1, step 2, step 3, step 4. Easy peasy. Easy algebra right there. You just know what to do. And then We learned about composite functions last week. Now what are we doing? We're just learning this definition. Okay? So bam. I'm going to end this video, and I'll catch you in the fun.